Hello, so let us look at these great homework questions together. The first one is to rationalize the denominator in each of the following. Okay, so here it goes. The first one is rather simple. We just have to multiply top and bottom by the conjugate here. Then we're going to multiply by square root of 11 minus 3. Square root of 11 minus 3. Then on top, we will end up getting 4 times square root of 11 minus 3. How about on the bottom? This will be the difference of squares, as you can see. So we get 11 minus 9, because square of 3 becomes 9. Then we realize that this portion is equal to 2. So 2 and 4 cancels out, becomes 2. So we end up getting 2 times square root of 11 minus 3 is our final answer. Now, how about B? In this case, we have cube root in each cases. So now you can refer to this idea. If I have a to the cube plus b to the cube can be actually factored as a plus b times a squared minus ab plus b squared. Now, in other words, if I want to cube a and b, then what I need to do is I just need to multiply this factor. So, if in order for me to get rid of the cube root, I need to cube this one, meaning I need to have this picture right over here. So in other words, a and b, a plus b is equal to this one. So that means I need to multiply this to top and bottom. Since a is cube root of 5, and that means a squared becomes cube root of 5 squared minus a and b are these two things. So cube root of 15, because we're multiplying by these two things, plus square of cube root of 3, so cube root of 3 squared. So I am multiplying that top and bottom. Then on the bottom, these two products multiplied into this way, so that we get to cube each one. So we will end up getting 5 plus 3, because cube root of 5 becomes 5. Cube of cube root of 3 becomes 3. And then top becomes 8 times so that's what we're getting. I'm just going to extend this one. But notice that this is 8, that's 8. So our answer is simply that's what's left, because 8 and then denominator canceled out. All right, so once again, if you want to look into this one, the bottom idea, you can refer to the reference video. All right, let's look at the next question. Here we have, we have 3 things. So as we have talked about it in class, I don't know how to do all 3 at the same time, but maybe I'll just do one at a time. So first, maybe I'll multiply top and bottom by radical 2 plus radical 3 minus 5, or radical 5. So here, radical 2 plus radical 3 minus radical 5. That means I'm considering radical 2 plus radical 3 as 1 unit. Then having plus radical 5 versus minus radical 5, hence I have conjugate-like expression. Then, first, I'll be getting the square of this green expression right over here, minus square root of 5. So what do I get for square of radical 2 plus radical 3? That becomes 2, first one square, plus 2 times of the product, which is radical 6, and then plus the last one, which is plus 5. And plus 3, I mean. That's the square of the first expression, and then second one is minus 5. All right, but the top one was 2 radical 6 times radical 2 plus radical 3 minus radical 5. But then we get to realize something quite interesting. 5 cancels out with 2 and 3 and then 2 radical 6 is left, but that cancels out with the numerator. So therefore our answer is simply radical 2 plus radical 3 minus radical 5. Done. All right, nice. So let's move on to the next question. Number D. Then here we get to see the top and bottom is very similar, except that the bottom one has a negative sign here. Top one has positive sign. So if I want to rationalize the denominator, what I need to do is actually I need to multiply by everything the same except the expression on the top. So in other words, I'm going to multiply by square root of 4 plus 2 square root of 3 plus square root of 4 minus 2 square root of 3. Now, then when I do that, then simply it becomes the numerator would have been squared. Let's look at the denominator first. Now we have, by the difference of squares, we will end up getting square of this one, which is 4 plus 2 radical 3 minus square of the second one, which is 4 minus 2 radical 3. Then you can see that 4 cancels out and denominator becomes 2 radical 3 minus minus becomes positive plus 2 radical 3. So our denominator becomes 4 radical 3. Let's look at the numerator here. When I square this one, then I'll be getting square of this one, which is 4 plus 2 radical 3 plus 2 times of the product between those two. So 4 plus 2 radical 3 times this one, which is 4 minus 2 radical 3, but those are conjugate in itself. And plus the square of this expression, we get 4 minus 2 radical 3. Then interestingly, you get to see that 2 radical 3 cancels out here. And then 4 plus 4 becomes 8. Plus 2 times. Here, this becomes the product becomes conjugate already. So we end up getting difference of squares. So we get square of 4, which becomes 16. Minus square of 2 radical 3, which is 12. And we know that that's equal to 4. So square root of 4 becomes 2. So hence, what we end up getting is this. Top becomes 8 plus 4 becomes 12 over 4 radical 3. Then obviously 4s can cancel out. We get 3 over radical 3. But when you rationalize this one, we'll end up getting radical 3 as our answer. All right. It's quite nice. Let's look at the next question. How about this? They want us to evaluate this product. It looks quite complicated. Let's see what we can do with it. Did you realize that I can, for the first one, I can assume that radical 5 plus radical 6 as the one pair, and then plus radical 7 and minus radical 7. Then what will I end up getting? So the first portion becomes square of the red expression here. That means I'm getting 5 plus 2 times of these two, which is radical 30 plus 6. Now, that's the square of the red expression minus square of the square root of 7 becomes simply 7 in this way. So the first part, I'm just looking at the first part, becomes 5 plus 6, which is 11 minus 7 becomes 4 plus 2 radical 30. That becomes the first expression. How about the second one? Notice that radical 7 is the same, but these has different signs. So if I were to rewrite it, Did you see that I can rewrite this one as radical 7 plus radical 5 minus radical 6. The reason why I have done that is so that I could have the negative sign in the middle. And this one is radical 7. Now, if I were to factor negative sign out between these two expressions, then I'll be getting negative radical 5. And then plus, in order for you to get plus sign, then we've got to have minus radical 6. That's what I'll be getting. Look at the last expression, see if that matches with the bottom one. All right, then you consider these two expressions, these two green expressions becomes the conjugate of each other. So when I multiply them, the first portion is this one. Radical 7 times radical 7 is simply 7. Now minus radical 5 minus radical 6 squared, so we end up getting 5, which is square root of radical 5, minus 2 times of these two product, which is radical 30, and then plus 6. Then 7 minus 5 minus 6 becomes negative 4. But negative becomes positive, so positive 2 radical 30. Then, did you realize that this one is conjugated one more time between the red and green? If you want to see it a little bit different way, then we can rewrite it as 2 radical 30 plus 4, and then 2 radical 30 minus 4. I can rewrite these two expressions in this manner. Then you might be able to see that pair a bit better. Now here we have, then by the difference of squares, so square of 2 radical 30 becomes 120, minus square of 4 becomes 16. So we end up getting 104 becomes our final answer. All right, let's move on to the next question. Number 14.3.3. All right, so we want to, basically what we want to do is, I don't know, maybe we'll try to rationalize the denominator. But we have square root and cube root combined together. So what if we were to get rid of the square root first? Because that seems to be easiest. So I'm going to multiply by its conjugate, so which is radical 2 plus cube root of radical 2. So radical 2 plus cube root of radical 2. Then top is radical 2 plus cube root of radical 2. The bottom becomes square of radical 2 becomes 2. And then minus cube root of 2, square of that becomes minus cube root of 4. So we realized how we can get rid of the square root. Now we have issue with cube root. How are we going to get rid of cube root? If you remember earlier in the homework, I'm going to be using this idea to get rid of cube root, a cubed plus b cubed. In this case, it's connected with the minus sign, so let me just use the minus sign here then to see better. Is a minus b, which is what's given, times a squared plus ab plus b squared. Now, so basically I need, since this one is already given here, I just need to multiply by this one top and bottom, then I'll be able to cube each component. So I'm going to multiply the denominator by, first one is square of a. Since a is 2, so I'm going to multiply that by 4. Plus, the second one is product of these two, so we get 2 cube root of 4. The last one is square of that one, so we end up getting plus cube root of 16. But did you realize that cube root of 16 is in fact 2 cube root of 2? So I'm just going to rewrite that in this way. That's equal to 2 cube root of 2. So I'm going to multiply this one more time. 4 plus 2 cube root of 4 plus 2 cube root of 2. Now, then what do I get? Denominator becomes rather simple because denominator now becomes here cube. I just have to cube each one. Then cube of 2 becomes 8 minus cube of the cube root of 4 becomes 4. So denominator becomes 4. How about the numerator? I guess we just have to multiply each one here. So when I multiply radical 2 to each one, I'll be getting 4 radical 2, and then here it becomes plus 2 times radical 2 times cube root of 4, and then the last one becomes plus 2 radical 2 cube root of 2. Now I'm going to multiply cube root of 2 to all of them. Then I guess it becomes a little bit long here. So then I get 4 times plus 4 times cube root of 2. Next one is cube root of 2 times cube root of 4 becomes cube root of 8. But cube root of 8 is 2, so 2 times 2 becomes 4. Now the last one becomes 2 plus 2 cube root of 4. Now, then if I have to express everything in terms of power of 2, we realize that the denominator is 4. 8 minus 4 becomes 4. 4 is 2 squared. How about the first term? First term here we get this one is 2 squared, and this one is 2 to the 1/2 power. So we in the first term becomes 2 to the 2.5. Or I'll just put it this way. So 5 over 2. Second one, here exponent is 1, here exponent is 1/2, and here exponent is 2/3. Because 4 is 2, and then cube root is 1/3. So when I combine them together, what do I get? So I'll be getting 2 to the, so I could have 6, 3, which is 9, and then, so 11 over, 6, 9, and then this becomes 4 when I have base of 6. Then we get 13 over 6 plus, here I get the exponent is 1, exponent is 1/2, and exponent is 1/3. So base, the denominator of the exponent becomes 6. So here I get 6 and 3, which is 9, and then 2 becomes 11. So 2 to the 11 over 6 power. And here I get this becomes exponent is 2, and here exponent is 1/3. So we end up getting 7 over 3. Now here this is 2 to the 2nd power, and here I'll be getting exponent is 2, and then here exponent is 2/3. So I end up getting plus 2 to the 8 over 3. But if I were to divide by 2 squared, since none of them has the same exponent, the first term becomes 2 to the 1/2 power, because I have to subtract 2 from the exponent. Second one is 2 to the 1/6 power. Third one is plus 2 to the negative 1/6 power. The next one is plus 2 to the 1/3 power. And next one is 2 to the 0 power. The next one is 2 to the 2/3 power. So I expressed my answer in terms of a sum of 2 to the exponents, where the exponents are rational numbers right here. All right, so that was fun. Let's look at the next question. Number 14.3.4. Show that 1 over 10 is less than this expression. How are we going to do that? Because denominator is 10 in the fraction, so what if I put it over 1? Then one thing that which we get to realize is instead of multiplying top and bottom by multiplying by conjugate of the denominator, maybe what if we have to multiply top and bottom by conjugate of the numerator? So radical 101 plus radical 99 over radical 101 plus radical 99. Then you get to see that here 1 over 10 has to be less than 2 because difference of square. So we get 2 over radical 101 plus radical 99. Then if I were to multiply top and bottom by 10, left and right by 10, you get to realize that this implies 1 is less than 20 over square root of 101 plus square root of 99. That means 20 has to be greater than this one. This implies that 20 is greater than, that's how we can have fraction to be greater than 1. 20 is greater than square root of 101 plus square root of 99. But 101 and 99 is so closely related with 100. So that means if I were to rewrite this one, then this would be equal to 20 is greater than square root of 100 plus 1 plus second one is 100 minus 1. Since all values are positive, even if I were to square each side, the inequality sign wouldn't change. So if I were to square both sides, then I'd be getting 400 is greater than, this one now becomes 100 plus 1 plus 2 times 100 plus 1 times 100 minus 1 plus 100 minus 1, squaring the second term. But as you can see, plus 1 and minus 1 would have canceled out. And we have 200. So when we subtract 200 from each side, then we get 200 is greater than 2 times square root of, here we get 100 squared minus 1. When I divide by 2, I'll be getting 100 is greater than square root of 100 squared minus 1. But if I were to rewrite 100 in form of square root and then square, then we'll end up getting 100 is square root of 100 squared has to be greater than minus 1. Obviously, when we subtract 1 from this 100 squared, this portion would have been less than this portion. So there it goes. That's how we can show it. All right, with this one, we'll stop, and I'll see you later. Bye-bye.